Just looking at a few problems with the homework and some more examples from exercise 15. First part is to simplify this expression, so we'll expand it. We get cos x cos y minus sin x sin y plus cos x cos y plus sin x sin y. So two of the terms cancel, and we've got two lots of cos x cos y. And that's part A. And part B of the question says, hence, an expression for cos 50 cos 65. Now, we know that cos x plus y plus cos of x minus y equals 2 times cos x cos y. So this would mean, if you want an expression for that, we know that, for example, 2 cos 50 cos 65 would be equal to cos of x, which is 50 plus 65, plus the cos of... Now, I'd rather it be positive. I don't think it matters which way I write this, so I'm going to go cos of 65 plus 50. Well, it wouldn't matter. You know why? Because cos of negative 15 equals cos of 15 anyway. And cos of 65 minus 50. So let's say I did go 50 plus 65, 50 minus 65. I'd get cos of negative 15 here, which is the same as cos of 15. Because in quadrant 4, cos of negative 15 equals cos 15. Okay, so that's what 2 cos that is. Are we okay with that? So therefore, the cos of 50 degrees cos 65 degrees will be this expression divided by 2. So this is cos of 115 degrees plus cos of 15 degrees divided by 2. Okay, now, I don't know if they simplify further and rewrite cos of 115 as negative cos whatever, or no? Yeah, they write it as negative cos. So, or they leave it like this. Yeah. All right. 14F, expand tan of x plus 2y. So, we've got tan of x plus 2y is using just the expansion, the sums and differences result, is tan of x plus tan of 2y over 1 minus tan of x times tan of 2y. Now, we need to come up with an expression for tan of 2y within that. So we've got, we're going to need a bit of room here. We've got tan of x plus, now tan of 2y, isn't it 2 tan y over 1 minus tan squared y divided by 1 minus tan x times 2 tan y over 1 minus tan squared y. Now, we want to get rid of the fractions, don't we? So all the denominator, so you're best off just multiplying each term, or multiplying numerator and denominator by 1 minus tan squared y. That will eliminate the denominators within the fractions, within the fraction. So if you multiply numerator and denominator by 1 minus tan squared y, you lose this 1 minus tan squared y and you lose this one. Okay, so we've got tan of x times bracket 1 minus tan squared y plus, if we multiply this by 1 minus tan squared y, cancels with the denominator, plus 2 tan y over, multiply the first term by 1 minus tan squared y, and you get 1 minus tan squared y minus, now this whole thing is a term, so if you multiply by 1 minus tan squared y, you just lose the denominator, minus tan of x times 2 tan y. Now, I suppose we could either leave it like that, or we could expand if we want, if we can expand out the brackets. Tan of x minus tan x tan squared y plus 2 tan y over the same denominator, 1 minus tan squared y minus 2 tan x tan y. Just going to look at triple angles here. So, triple angle results. Now, triple angle results are not given to you. You have to be able to derive them. They are not on the formula sheet. So, triple angle results. So, we're going to write an expression for sine. So, we're going to write an expression for sine 3 theta. We're going to do it for sine 3 theta, cos 3 theta, tan 3 theta in terms of theta. In other words, you're not allowed to have any double angles or whatever in your expression. So we will start with taking sine 3 theta is the same as sine of 2 theta plus theta, or you could write it as theta plus 2 theta, it wouldn't matter. We're going to do the normal sums and differences expansion, and then we're going to do the double angle result expansion. So that is, keep the sign the same, sine 2 theta cos, anyone? Theta plus cos 2 theta sine theta, which is expanding sine 2 theta is 2 sine theta cos theta. We've got 2 sine theta cos theta times cos theta plus, now the expansion for cos 2 theta, there's 3 to choose from. Let's just do cos squared minus sine squared to start with, plus cos squared theta minus sine squared theta times sine theta. Okay, now we have to write an expression for sine 3 theta in terms of theta. We tend to, we actually write it in terms of sine theta. We want to write the expression for sine 3 theta in terms of sine theta. So what have I got here? 2 sine theta what? Cos squared theta plus, now I'm expand, actually what I could do here, I can expand, but what I could also do is change my cos squared theta into 1 minus sine squared theta if I eventually want to come up with an expression for sine 3 theta in terms of sine theta. So what I could really do here is I could have written this as the 1 minus 2 sine squared theta result in the first place. Are we okay with that? So I might actually change that and write it as the 1 minus 2 sine squared theta result, because really cos squared theta is 1 minus sine squared theta. Now, before I go expanding, I'm going to write here cos squared theta as 1 minus sine squared theta. Often they'll ask you to show that sine 3 theta equals this result all in terms of sine theta. They will tell you, write sine 3 theta in terms of sine theta. All right? Plus, are we okay with that? Cos squared theta is 1 minus sine squared theta. I decided to change from this version and write it as 1 minus 2 sine squared theta. So let's expand. What have we got? Plus sine theta, what have we got now? Minus, I'm expanding, minus 2 sine cubed theta. And let's expand the first bracket as well. 2 sine theta minus 2 sine cubed theta plus sine theta minus 4 sine cubed theta, which is, what have we got? 3 sine theta minus 4 sine cubed theta. Sorry, yeah, it's not, it's 2. Because I'm thinking of the result. I'm thinking of the result being 4. So minus 2 sine cubed theta there, sorry. And then the result is sine 3 theta. So this is our result, that sine 3 theta equals 3 sine theta minus 4 sine cubed theta. Okay, so you'll sometimes be asked to derive that result. You won't be expected to know it, okay? But you should be familiar with it. See how we've written an expression for sine 3 theta in terms of sine theta, in terms of ordinary sine thetas. No sine 2 thetas, no cos 2 thetas, just all in terms of sine theta. Now we're going to do the same thing for cos 3 theta. So write an expression for cos 3 theta, also in terms of cos theta. So write an expression for cos 3 theta in terms of cos theta. So we're going to start off the same way. Cos of 3 theta equals cos of 2 theta. So I'm just going to go cos of 3 theta equals cos of 2 theta plus theta. That's how we start. Plus or minus sine sine. Cos 2 theta, cos theta, minus sine 2 theta, sine theta. Now remember, we want to write cos 3 theta in terms of cos theta. I have got 3 choices for cos 2 theta. Which one are we going to use? 2 cos squared theta minus 1. Okay, so let's use 2 cos squared theta minus 1 times cos theta minus, there's only one expansion for sine 2 theta, which is 2 sine theta cos theta, and then we're still multiplying that by cos theta. It's by sine theta, sorry, by sine theta. So times sine theta. So let's expand this. We've got 2 cos cubed theta minus cos theta minus, I'm going to go 2 cos theta times sine squared theta. Now I could have just written that sine squared theta as 1 minus cos squared straight away if I wanted, which is 2 cos cubed theta minus cos theta minus 2 cos theta times, we know that sine squared theta is 1 minus cos squared theta. So it's 2 cos cubed theta minus cos theta minus 2 cos theta minus 2 cos cubed theta. And so therefore the result for cos 3 theta plus, thank you. So therefore the result for the cos cubed theta, cos 3 theta is 4 cos cubed theta minus 3 cos theta. If you look at it and compare it to the sine result, they're sort of opposites. Here the sine is positive, the cos is the minus 3 cos, and that's minus 4 sine cubed, and this is plus 4 cos cubed. So they're sort of like opposites of each other. Write an expression for tan 3 theta in terms of tan theta. We do it in the same way. Tan 3 theta equals tan 2 theta plus theta, which is tan 2 theta plus tan theta over 1 minus tan 2 theta times tan theta. Then we apply the double angle result for tan as well, which is 2 tan theta over 1 minus tan squared theta plus tan theta minus tan of 2 theta times tan theta. I'm going to write the tan theta first, and then I'm going to put the tan 2 theta next to it, which is 2 tan theta over 1 minus tan squared theta. It doesn't really matter anyway. But I wrote here the tan theta first and then did the expansion for tan 2 theta. Now, what will we do? Multiply? How do we get, yeah. So multiply numerator and denominator, or multiply through by 1 minus tan squared theta. So when you multiply the first term by 1 minus tan squared theta, you get 2 tan theta plus, multiplying the second term, you get tan theta times 1 minus tan squared theta. Multiplying this, the 1, you get 1 minus tan squared theta minus, and this whole thing is one term. And if you multiply that by 1 minus tan squared theta, you're just left with the numerator, which is tan theta times 2 tan theta. I probably should have left it the other way, but it doesn't matter. Now we just expand. So we've got 2 tan theta plus tan theta plus tan cubed theta over, yes it is minus tan cubed theta over 1 minus tan squared theta minus 2 tan squared theta. Should have just kept those the other way. Doesn't matter. And now what do we get? Always put the positive term first. So it's 3 tan theta minus tan cubed theta over 1 minus 3 tan squared theta. So this one has a combination of tan theta, tan cubed theta, and tan squared theta. So they're all in terms of tan theta. Okay? Because that tan cubed theta is tan theta times tan theta times tan theta, and tan squared theta is tan theta times tan theta. And so therefore tan of 3 theta equals 3 tan theta minus tan cubed theta over 1 minus 3 tan squared theta. And you do not have to memorize these results, all right? You'll be asked to derive them. Everyone can try the next question. Express sine 4 theta in terms of theta. So what do you think you would do? Sine of 4 theta equals sine of, what do you think? 2 theta plus 2 theta. Now, which is, why don't we do it another way? Yeah, I can do that expansion, but why don't I do it as sine of 2 lots of 2 theta? Because that's, are you okay with that? So pretend this 2 theta is my theta. Or if you want, if you think you're going to get confused, why don't I let x equal 2 theta, and then we'll replace the x at the, actually we're going to have to expand. We're going to have to do it later anyway. Let's see if you can do it this way. All right. Or you want to do it the other way. I think you're all going to prefer the long way at the moment, but so we're just beginning. We'll leave this way for a bit later. We might try it that way later. So what do we get here? Because isn't it just going to be the same thing twice? Sine 2 theta cos 2 theta plus cos 2 theta sine 2 theta. Oh no, this is good. Because then now let's write it as one thing. So don't do each one separately. Isn't it sine of that, cos of that, plus cos of that, sine of that? Aren't they the same? So that now is two lots of sine 2 theta, cos 2 theta. And that's what would have happened if I would have, so let's say I did write it as sine of 2 times 2 theta, I would have got this. 2 sine whatever in the bracket, cos whatever's in the bracket, I would have gone straight to that step. So that's okay. It's fine to do it this way. But can you see that they're the same? All right. Which is, so I'm just going to put it in brackets. That's really equal to sine of 2 times 2 theta, which is, and you could go straight to there, which is sine of 2x is 2 sine x cos x, for example. So it's 2 sine that cos that, which is what we had there. All right. Now, let's expand. Which expansion for sine? There's only one of them. 2 sine theta cos theta times the expansion for cos. I'm going to do the sine squared one. We'll just see what happens. Times 1 minus 2 sine squared theta. I don't think we can write this all in terms of, look, I don't think we can write it in terms of sine squared theta anyway, because we've only got a cos theta. Do you understand? So it does not matter which version of the result that you chose. You could do 1 minus 2 sine squared, 2 cos squared theta minus 1, cos squared minus sine squared. But because we're only ever going to have a cos theta, we're never going to be able to write this in terms of sine theta only. That would have had to have been a cos squared theta, and then we could have written it as 1 minus sine squared, but we don't have that. So what I'm going to do, I'm just going to write this as the cos squared theta minus sine squared theta 1, knowing, and it doesn't matter, you wouldn't get marked down, knowing that I'm not going to be able to eliminate cos theta anyway. But you may get a bit of symmetry sort of this way. So we've got 4, isn't this 4 sine theta cos cubed theta minus 4 sine cubed theta cos theta. See how there's a bit of a relationship between them, okay? For question 20. Now, you know, it says simplify sine of 2x over 1 plus cos 2x, hence find the exact value for tan 15. You know, we can find the exact value for tan 15 using sums and differences. Do you remember that? Tan of 15 would be tan of 45 minus 30 in brackets, or tan of 60 minus 45. But this is another way we can find the exact value for tan 15, right? So remember, we only know exact values for 30, 45 and 60. So any combination of 30, 45 and 60, we can use sums and differences. But however, they're asking us to find a exact value for tan 15 using another method this time. So let's start with part A, simplify sine of 2x over 1 plus cos of 2x. What do you think we should do? Double angles. We've got 2 sine x cos x over. Now, this is where the choice of which double angle result makes a big difference. Huge difference. 1 plus. Now, I don't want 3 terms on my denominator, or 2. I prefer to have 1 term on my denominator. So which one's going to cancel out with the 1? If I've got 3 choices. Cos of 2x is cos squared x minus sine squared x. Now, that's just going to make the denominator look a mess. The other choice I've got is 2 cos squared x minus 1. Now, that's a really good choice because I write 1 plus 2 cos squared x minus 1. Why is that a great choice? Because the 1's cancel and I'm only left with one term on the denominator, and I can cancel out between the numerator and the denominator. The other choice was 1 minus 2 sine squared x. That one's not as good because you end up with 1 plus 1 minus 2 sine squared x. Actually, it may work because you can factorize out the 2 that way as well. You'd end up with 2 minus 2 sine squared x. You can take it out as a common factor. That probably would have worked as well. But this is the best choice because what have we got? 2 sine x cos x over 1 minus 1 is 0 over 2 cos squared x. Now, what does that simplify to? So these were my 3 choices. So this is where your choice of cos 2x is really important. There's only ever one choice for sine 2x. But there are 3 choices for cos of 2x. And when you've got a 1 plus something on the denominator, you always do the 2 cos squared x minus 1. If I had here cos 2x minus 1, I would have chosen the sine one. 1 minus 2 sine squared x, because the 1's would have cancelled, all right? So what do I cancel? What am I left with? The 2's go. One of the cos's go. What have I got? Tan x. I'm left with the 2's go and one of the cos's go. So I'm left with sine x on cos x, aren't I? Which is tan x. Now, are we okay with this? So the question is, hence evaluate, find the exact value for tan 15. So what we do, we write it all out again. Sine of 2x equals 1 plus, sorry, I'm going to write it the other way, but tan of x equals, so for part B, hence evaluate tan of 15 degrees. Find the exact value. I know that sine of 2x over 1 plus cos 2x equals tan 15. So therefore, tan of x equals sine 2x on cos 2x. So I'm going to substitute x is 15 because I'm trying to come up with an expression for tan of 15. Why does this work really well? Because sine of what? Tan of 15 equals sine of 2 times 15 over 1 plus cos of 2 times 15. Which is, see why it works well? So it's sine 30 over 1 plus cos 30. Are we good? Which is a half divided by 1 plus root 3 on 2. Now what do I do with all these 2's on the denominator? What do I multiply through by? Multiply by through by 2. In other words, multiply the numerator and the denominator both by 2. A half times 2 is 1. 1 times 2 is 2. And root 3 on 2 times 2 is just root 3. I must rationalise that now. Which is, so I'm going to times that by 2 minus root 3 over 2 minus root 3. And so I get 2 minus root 3 over what? Over a plus b, a minus b is a squared minus b squared. So I'm rationalising now. So I got that, but I want to rationalise it. Over 4 minus 3, which is just 1. So tan of 15 is 2 minus root 3. Now to check that, you can just go to your calculator, press tan 15, keep a mental note of what it equals, cancel, and do 2 minus root 3 on your calculator and see that you get the same answer. All right? It's equal. 2 tan x over 1 minus tan squared x. So therefore, if you let x equal 22.5 degrees, actually let's just all right, let's do that. Let x equal 22.5 degrees. So the tan of 2 times 22.5 degrees equals 2 tan 22.5 degrees over 1 minus tan squared 22.5 degrees. Now what do I know? Isn't that tan 45? Which is what? All right, I'm writing this all out again, but and I probably don't need to, but tan 45 is 1, isn't it? So because it's 1, I'm just going to write here tan 45 equals 1. So that means that's 1. Can't I just cross multiply? So therefore 1 minus tan squared 22.5 degrees. So I've written here on the side tan 45 equals 1. So therefore 1 minus tan squared 22.5 degrees equals 2 tan of 22.5 degrees. What's this looking like? Like a what? Apart from messy. Quadratic. Where should I take everything, to the left or the right? Here's my squared term. To the right. Good. So it's tan squared 22.5 degrees. So that one's going over. Plus keep this one here. 2 tan 22.5 degrees. What about the 1? Take it over. Minus 1 equals 0. So that's your x. X is tan of, now I'm letting x equal tan of 22.5 degrees. Not just 22.5 degrees. All right. So see, this is really x squared plus 2x minus 1. That's really what it is. Now, let's just write it as, and I'll do it as y squared. Y squared plus 2y minus 1 equals 0. Can you? No, you can't. You can't factorize it. No. It'd have to be a plus 1. So you can't factorize that. So we're using quadratic. The quadratic formula where x is tan of 22.5 degrees. Are you okay with that? Because that's like x squared plus 2x minus 1. This is like, or I'll even call it y squared plus 2y, minus 1 is 0, where y is the tan of 22.5 degrees. Are you okay with that? Sure. So it's quadratic formula. What's A? 1. B is 2. C is -1. So tan of 22.5 degrees, that's your y, equals -b, which is -2, plus or minus the square root of b squared is 4, minus 4 times a times c is -1, over 2 times 1. Are we okay with that? Because that's 2 squared, that 4, okay? So it's -2 plus or minus the square root of 4 plus 4 is 8 over 2. We good? -2 plus or minus, what's square root of 8? 2 root 2 over 2. What should I do now? Divide through by 2. So it's -1 plus or minus root 2. Now, which one is it? I need you to think that tan of 22.5 degrees is an acute angle. Is it positive or negative? Tan of 22.5 degrees. All stations to central. It's positive. We have two options here. So you've got -1 plus root 2 or -1 minus root 2. It's not going to be -1 minus root 2 because this is negative. So it's not the solution to this. Not the solution. This is positive because root 2 is 1.414. So it's this one because this is positive. Remember, this is acute angle, quadrant 1. Are you okay with that? So therefore, tan of 22.5 degrees is, instead of writing it as -1 plus root 2, let's write it as root 2 minus 1. Now, do that on your calculator. Tan of 22.5 degrees, you should get about 0.414, and root 2 minus 1. The other solution is related, but it may be in the quadrant 2 or the quadrant 4 answer or something. Okay? Maybe. Right. Prove that sine squared theta equals half sine 2 theta tan theta. I wouldn't be starting from the left-hand side because really, what would you do? 1 minus cos squared, and then what would you do? So let's start with the right-hand side. Is 1/2 sine 2 theta times tan theta. Off you go. Try something. Side is 1/2. Sine 2 theta is 2 sine theta cos theta. These are all times. And tan theta is sine theta on cos theta. I think we're done. Don't you get a bit of cancelling? So the coses cancel, the 2's cancel, and you're left with sine theta times sine theta, which is sine squared theta, which equals the left-hand side. We haven't seen yet. Prove, we're supposed to prove that tan theta on 2 equals 1 minus cos theta over sine theta. What I'm going to do is, what we can notice, it actually is a double angle result, because notice the theta here is double the theta on 2, and notice the theta here is double the theta on 2. So before I start this, I'm going to write out the double angle results. So I'm not going to do this question yet. We're going to write out some half angle results because they're related to double angle results. So we're going to look at the half angle results. You know how sine of 2 theta equals 2 sine theta cos theta? Notice that the 2 theta is double the theta on the right hand side. So what the angle on the left is double the angle on the right. I can write the half angle result. Just as long as what's on the left is double what's on the right, the angle's on the right, sine theta would therefore be equal to what? 2 sine theta on 2 times cos of theta on 2. We okay with that? Similarly, cos of 2 theta. We know that it's cos squared theta minus sine squared theta. Hence, I could write out the double angle result for cos theta. Sorry, the half angle or the single angle. So as long as what's on the left is double what's on the right, isn't that cos squared theta on 2 minus sine squared theta on 2? We could actually do that result for all the 3 cos results. So the other ones would be cos of 2 theta is 2 cos squared theta minus 1. Writing it as a half angle result, that's cos theta is 2 cos squared theta on 2 minus 1. The other result for cos 2 theta is 1 minus 2 sine squared theta. So writing the half angle result, that would be 1 minus 2 sine squared theta on 2. And you could also do it for the tan result. Tan of 2 theta is 2 tan theta over 1 minus tan squared theta. So writing the half angle result with the single angle out the front, you're just halving every result, every angle, as long as the angle on the left-hand side is double the size of the angle on the right-hand side. Continuing from question 22, just continuing, prove that tan theta on 2 equals 1 minus cos theta over sine theta. So with this question, we notice that the theta on 2 here is half the size of these angles theta. So this alerts us, it alerts us that we need to use the double angle result. Even though you don't have 2 theta, see, double angle results are used when you've got 2 theta and theta in an equation, or if you've got theta and theta on 2, because one angle is double the other, all right? So if I divide that by 2, I get theta, this one by 2, I get theta on 2. So yes, I do use the double angle results. So I have to prove that tan theta on 2 equals this. I'm going to start with my right-hand side is 1 minus cos theta over sine theta. Now I need to use the double angle result for cos theta and for sine theta. The double angle result for sine theta, there's only one that I will use, and it'll be 2 sine theta on 2 cos theta on 2. Okay, that's the only one there is. But because I have a 1 on the numerator, be careful because it's 1 minus. So I need the one with just a normal 1. Because I don't want, if I put 2 cos squared theta minus 1, it's negative 1, which is plus 1. I want a 1 minus 1. So I go 1 minus. So I'm going to use cos theta is 1 minus 2 sine squared theta on 2. Remember, normally the result is cos 2 theta is 1 minus 2 sine squared theta. That's the normal result. That's how you'll recognize it. But we're going to use cos theta is 1 minus 2 sine squared theta on 2. And just what we've done with the sine theta, we know that sine 2 theta is 2 sine theta cos theta. So we're using sine theta is 2 sine theta on 2 cos theta on 2. Okay, so they're the double angle results that we're using, but we're halving them. So we'll call these the half angle results. So we want to use this one because 1 minus 2 sine squared theta on 2. Now that's 1 minus 1 plus 2 sine squared theta on 2 over 2 sine theta on 2 cos theta on 2. And the ones cancel, 1 minus 1, which is why you don't do the other result. So whenever you're using a double angle result and you've got a 1, you need to use the result that cancels, that'll give you 1 minus 1, not 1 plus 1. Okay, and then therefore we've got 2 sine squared theta on 2 over 2 sine theta on 2 cos theta on 2, and then you can cancel. The 2's cancel. A sine theta on one of the sine thetas on 2's cancel. So it's sine theta over 2 over cos theta over 2, because one of the sine thetas cancels with that. And you end up with tan theta on 2. Now this is all leading us into our T formula, which we're going to be doing next lesson, okay? They're called T formula and they're all based on tan theta on 2, okay? Equals the left-hand side. So it was just too difficult to start with the left-hand side, really. Where would you go if you started from the left-hand side? You wouldn't know what to do. So there's more to manipulate on the right-hand side. Questions from Cambridge. So prove that 1 minus tan squared alpha over 1 plus tan squared alpha equals cos of 2 alpha. Look, there's actually a few different ways you can do this if you want. I mean, yes, you can write them both as sine squared theta and cos squared theta, but what about our its and all that sort of stuff? You could maybe, I don't know, but yeah. So we could write them all as sine squared alpha on cos squared alpha, sine squared alpha on cos squared alpha. And then, so you can try it like that. Start with our left-hand side. We're going to try this 2 different ways. So you might choose to write tan squared alpha as sine squared alpha on cos squared alpha. So that's 1 minus sine squared alpha on cos squared alpha over 1 plus sine squared alpha over cos squared alpha. What would you then do? Multiply through by? Multiply by through by cos squared alpha. So you'd get cos squared alpha minus sine squared alpha over cos squared alpha plus, actually this is not bad, sine squared alpha. This is a good way to do it. Yep. Which is, isn't that the double angle result? So that's cos of 2 alpha, and cos squared plus sine squared is 1. You need to show that. You need to show all your steps, please, which is cos 2 alpha. The other thing you could do, just reminding you about the other results that we have, the other way we could have gone, maybe, is like this. Left-hand side is 1 minus tan squared alpha over 1 plus tan squared alpha. Now we know that 1 plus tan squared alpha is sec squared alpha. So if, down here, if 1 plus tan squared alpha is sec squared alpha, doesn't that mean that tan squared alpha is what? Sec squared alpha minus 1. I don't know if this is actually going to be any good. Oh, actually, no, I don't think it will be, because we're going minus negative 1, we're going to have 2 plus. So this method doesn't look good. Because you'd have 1 minus bracket sec squared alpha minus 1. Is that right? And that's not good, because we've got 2 minus sec squared alpha on sec squared alpha. Look, you could, but I think this is better. What would I do now if it was like this? It's not so bad because there's one denominator. Isn't that 2 over sec squared alpha minus, no, this is not good. This isn't leading us anywhere, is it? No. So we're going to leave this. No. It's 2 cos, actually 2 cos squared alpha minus 1. Well, it does. It does lead us somewhere. Can you see? 1 over sec is cos. Sec is the reciprocal of cos. So it's 2 cos squared alpha minus 1, which is the double angle result for cos, or one of the double angle results for cos. So there is, there's always more than one way to do these problems. Can you see this, everyone? All right, so that could work as well. Look, where you would stop and give up is if the denominator contained more than one thing and you couldn't really do much with it, maybe. Unless you could do a difference of 2 squares somewhere or whatever, but yeah. Find the exact value of 1 minus 2 sine squared 22.5 degrees. Do you recognize it as anything? You know that 1 minus 2 sine squared theta equals what? What's that the result for? What's it the result for? Cos of 2 theta. So that's going to equal cos of what? Yeah, 2 times 22.5 degrees, which is the cos of 45 degrees, which is 1 on root 2. Okay? Just so that you recognize those, all right? Acute angle, and cos theta is 4/5. Find the exact value of cos theta on 2. Yeah, a bit uncomfortable. Yep. What should I do? Don't worry about the theta on 2. Let's say you were just given this. What would you do? Triangle. Good. Let's do a triangle, because we're going to find the value of cos theta on 2 and sine theta on 2 and tan theta on 2 in a minute. So this is theta in my triangle, but right? 4/5 adjacent over hypotenuse. What's the other side? 3. What sort of thing? I've got cos theta and cos theta on 2. That's telling you about which result. It's the double angles. One angle's double the other, but you're going to use the half angles. So you know how, so you can always just write down what you are comfortable with, which is the double angle result. Cos 2 theta is, which one do you want to use? I don't mind. There's 3 to choose from. We just want cos of theta on 2, so let's go 2 cos squared theta minus 1. That's the result you know. But we can't use that. We're going to use half of that. Do you get it? Look, they're giving you theta. They're asking for theta on 2. This is indicating you must use the double angle results, but we're using it half. So that's what you know. So how do you write out the rule? Cos, as long as what's here is double that. Cos theta is 2 cos squared theta on 2 minus 1. Do you get that? We're telling you the value of cos theta, but we're asking you about theta on 2. This is telling you double angle results, but use half. You halve them. No, half the angle, as long as the angle out the front is double this. So we're using half angle results, which are really the double angle results, but with all the angles halved.
So you know how it's like cos theta equals that?
2 cos squared theta on 2 minus 1.
Yeah.
Yep.
Is that like is that cos theta on 2?
That bit is cos theta on 2.
Not
No, that's cos theta. Look, half of 2 theta is theta. Half of theta is theta on 2. So I'm using the double angle result with the angles halved, because I'm using theta and theta on 2. Okay? Now, do I know the value of cos theta? What is it? It's given in the question. 4/5. So 4/5 equals 2 cos squared theta on 2 minus 1. What do I do now? Add 1 and divide by 2. So 4/5 plus 1 divided by 2, are we okay with that? Equals cos squared theta on 2. I've just made cos squared theta on 2 the subject. So that plus 1 divided by 2. What's that? 9/10? Isn't this 9 over 5 divided by 2? 9/10? So 9/10 is cos squared theta on 2. Are we okay? So cos theta on 2 equals plus or minus the square root of 9/10. We want the exact value, by the way, which is plus or minus 3 over root 10. Now, it says theta is acute. If theta is acute, less than 90, do you think theta on 2 is also acute? Half of theta? Yeah. So in other words, cos of theta on 2 is the positive root 3 on 10. because that is in quadrant 1. So if cos theta is positive, you're quadrant 1 or 4. If cos theta, so it's not, cos theta on 2 is negative 3 on root 10, would be quadrant 2 or 3 result. Does that make sense? How would you work out sine theta on 2? So, look, how do you recognize this question? They give you cos theta, they want you to find cos theta on 2. This is indicating this angle is double that one. It's the double angle result. Write it out, but then halve them. Don't half the thing. Don't write minus a half here or 1 here. It's halve the angles. As long as the angle out the front here is double this one, the angle out the front is double that one. All right, now you have to come up with an expression for sine theta on 2. Again, I'll draw up the right angle triangle. Here we go. We want an expression for sine theta on 2, and then we want one for tan theta on 2. Sine theta on 2, where we're going to get, we can use the cos result again. Yes. Why don't we still use the double angle result? Cos of 2 theta is, you could use the double angle result for sine, I suppose. You could use anything. You could use any of the 3. You just can't use, because we know what, I would do this one. So that you've only got, wait, 1 minus 2 sine squared theta. We're not using that one. Which one are we using? Cos of theta is 1 minus 2 sine squared theta on 2. Do you see why I use this one? I know what cos theta is, and they want me to find sine theta on 2. Yeah? So cos theta we know is 4/5. Guys, you can't use the triangle for theta on 2 angles. That triangle is only used for theta angles because we were told cos of theta is 4/5. I know I haven't used the sine result here, but all right. I could have, I can show you another way of doing it, but what have we got? 1 minus 2 sine squared theta on 2. I'm going to make sine squared theta on 2 the subject by taking it to the left. Sine squared theta on 2 is 1 minus 4/5 divided by 2. Are we okay with that? Because if I take this over, keep the 1 there, the 4/5 comes over, divide by 2. Okay. So sine squared theta on 2 is 1/5 divided by 10. Isn't that 1/10? And sine of theta on 2 is plus or minus the square root of 1/10, which is plus or minus 1 and root 10. And again, quadrant 1. So sine theta on 2 equals positive 1 and root 10. As sine theta on 2 has to be greater than 0 in quadrant 1. Since theta is acute. You were told that theta was acute. So if theta's 80, for example, theta on 2 would be 40. And how would you do, now that we've got sine theta on 2 and cos theta on 2, how would you find tan theta on 2? I would just do sine theta on 2 divided by cos theta on 2. So I might just put it here. So tan theta on 2 would be sine theta on 2 divided by cos theta on 2. You could use the tan. Could we use the tan? You could use the tan double angle result if you wanted. With tan theta equals 2, but then you'd have to solve a quadratic, I think. Be a bit messier. We can try it. So that's 3 over root 10 divided by 1 on root 10, which is, you know, if the denominators are the same, you can just divide the numerators, because doesn't that become times root 10 on 1? That's just 3. 1 on root 10 divided by 3 on root 10, which is a third. Okay, it's a third. Now, you can check this. You know how cos theta is 4/5? Of course, you'd never do this as your method in the exam, but shift cos 4/5 of, and you should get the angle for theta. Have you got an angle? Cos of what is 4/5? Give me the angle. Cos to the -1, 4/5. What do you get? 52 minutes, that one? Now, divide that angle by 2, 18 degrees, 26 minutes, whatever, and do the tan of that angle, and you should get a third. Roughly. No? Check. But of course, we would never accept that as a method in your exam. All right? Square root of a half, 1 plus cos of 40. So we've got to see where this is all coming from. Okay? Now, it will be from double angle results, definitely. And you'll come to notice when you see this half bracket, it's because it was 2 something and then we divided by 2 and that's how we got that. Let's just write our double angle results for cos. Cos of 2 theta, for example, is 1 minus 2 sine squared theta. See, that wouldn't be a bad one to use. Or, no, it would not be a good one. Or it's 2 cos squared theta minus 1. See how we've got the square root of a half times this? I want that 1 to go. So if I know that cos of 2 theta is 2 cos squared theta minus 1, I'm going to use double angle results here. So if I've got that, and I've got cos 40 here, wouldn't cos 40 be 2 cos squared what? 20 minus 1. Why don't I replace this cos 40 with 2 cos squared 20 minus 1? Do you know why I'm doing that? Because this 1 will cancel. Okay? So that is equal to the square root of a half. 1 plus cos of 40, I'm going to replace with 2 cos squared 20 minus 1. Which is the square root of a half times what? 2 cos squared 20. What happens with the half and the 2? They cancel. It's just the square root of cos squared 20. Do you know cos squared 20 means cos 20 times cos 20? That really means cos of 20 squared. That's how you write cos 20 squared. What's the answer? It's cos 20. It's cos of 20. You don't actually have to work it out, but that's how you would simplify that expression. So I know that one's a little bit tricky to see, but when you see this half bracket 1 plus cos, this often means the double angle result for cos. Remember, there are 3 you can choose from. We want the one that's going to cancel out the 1. All right. Let's try and use the double angle results again. But you've got to be careful. Are you going to do cos? Let's just see what we know. We'd like this 1 to go. I'm just going to write cos of 2 theta. What's cos of 2 theta again? Which one are we going to use? 1 minus, we want 1 minus 1, don't we? Let's do this one. 1 minus 2 sine squared theta, yeah? Because when I do that, but girls, I don't put in that. I don't have cos of 2 theta. What have I got? So I can, as long as the angle out the front is double this one, so what would cos 6 theta be? 1 minus 2 sine squared? 30. Oh, 6 theta. Sorry, that's not a 30. Let me just check the question. It's a 6 theta. 6 theta. So I'm trying to simplify this. 1 minus cos of 6 theta. And because I've got this 1 minus thing, I'm thinking double angle result for cos. I want that 1 to go, all right? Look, the question does tell you use the double angle results, all right? It does. It guides you. So I'm thinking which double angle result? It's not going to be cos squared minus sine squared. It's either going to be 1 minus 2 sine squared or 2 cos squared minus 1. This is not good, this one, is it? It's the other one. Is that going to... Oh, no, it is. It is. So what does this 1 minus... Sorry, girls. What would I do?
Oh, that's not 30, that's 50.
That's 3 theta, sorry. So 1 minus 2 sine squared 3 theta. We will use that one because the ones cancel, don't they? What is... Yeah. Okay with that. So what's this? 1 minus 1, what? Plus 2 sine squared 3 theta, which is just 2 sine squared 3 theta. It's not that much simpler. Simplifying, just simplifying. We're just simplifying. Not that it looks much simpler, but theta is a third. So draw a right angle triangle. Sine theta is 1/3. You can work out the missing side. Square root of what? 8. Because it's 3 squared minus 1 squared is 8. Which is 2 root 2, right? And we know that cos theta is negative. If sine theta is a third, which is positive, cos theta is negative, what quadrant are you in? That's telling you a certain quadrant. Quadrant 2. Sine is only positive in 1 and 2. Cos is negative in 2 and 3. We're definitely in quadrant 2. We need the exact value for tan 2 theta. Now, what about tan? Is tan positive or negative in quadrant 2? All right, so quadrant 2, therefore, that gives me that tan theta is negative. So tan of 2 theta is 2 tan theta over 1 minus tan squared theta. So they want you to find the exact value of tan 2 theta. And we can, but we have to put negatives. Tan of theta is negative. So according to this diagram, tan theta is 1 on root 8, but it's quadrant 2, so we have to go negative. You got it? You must do that because otherwise they wouldn't tell you all this stuff about sine theta is positive and cos theta is negative. That's setting the scene for the quadrant, okay? Triangle result will be the same, but you've got to put the tan is negative. So what have you got? 2 times what? Negative 1 on root 8 over 1 minus negative 1 on root 8 squared, which is negative 2 on root 8 divided by, what's this? 1 minus an eighth, isn't it? Divided by 7/8, isn't it? It's actually divided by 7/8 because it's 1 minus 1/8. Negative 1 on root 8 squared is just positive 1/8. 1 minus 1/8 is 7/8. So negative 2 on root 8 divided by 7/8 is negative 2 on root 8 times 8 on 7. 8 on root 8 is root 8 because that's root 8 squared. And you keep the 2 and the 7 and the negative. No? You've got negative 2. 8 on root 8 is root 8 because look, 8 on root 8, 8 is root 8 squared. 8 is root 8 squared, yeah? All right, that's it for today.